a splitter, a wing, a diffuser. None of that comes for free. Every aerodynamic component you add increases weight. The T50s makes up to 1500 kilos of downforce. That's basically strapping a whole Ferrari F80 to the roof. And that load has to go somewhere. It travels through the wing, into the mounts, down through the suspension, and into the tires. Every single piece in that chain has to be strong enough to withstand that kind of force, which means more weight gets added along the way. So, how is it possible that the T50s ended up over 100 kilos lighter than the road-going T50? And that's where the real engineering starts. The road-going T50 was designed to look almost untouched by aerodynamics. Gordon Murray kept the surfaces clean and pushed nearly all the aero work underneath the car, out of sight. The T50s takes a different approach. Right away, there's the splitter sitting low, working with the rear wing to keep the car balanced when the downforce comes. Above it, cut into the hood, are 3 NACA ducts. You'll recognize the shape. It shows up across a lot of performance cars. It's a way to get air into the car without the drag penalty of a traditional scoop. The outer 2 feed the front brakes, the center one feeds fresh air into the cabin. The first car shown to the public was a static clay model, and the inlets under the headlights and the rear grille were blanked off. Once the running prototypes appeared, both were open again. My guess on the headlight inlets is that the brakes need more cooling than the NACA ducts can provide on their own. One quick detail at the front, the wiper has been relocated. Instead of sitting low, like on the T50, it's now centered and vertical. Not a major change, just another way of reducing drag. Look just ahead of the front wheels and you'll notice the dive planes. Small aero elements that tidy up the messy air coming off the tires before it disrupts airflow further down the car. Now look at the car from the side. 2 things stand out immediately. First, the barge boards running along the bottom of the doors, exposing far more of the front wheel than the T50 ever did. We'll come back to why. For now, just note they're there. Second, the ride height. The T50s sits roughly 30 mm lower than the T50. Lower center of gravity, better aero efficiency close to the ground, and no chance of clearing a speed bump ever again. Up top, there's a fin running from the roof to the back of the car. That one's straightforward, yaw stability. At high speed, especially through fast corners, a surface like that helps the car pointed where you want it instead of wanting to rotate. At the back, the wing is enormous, almost 1.8 meters wide. Murray borrowed the shape from his own past. It's based on the front wing of his 1983 Brabham Formula 1 car. It works with the front splitter to keep the car balanced so it doesn't get unsettled mid-corner. All that extra downforce ends up as load on the tires, so the T50s gets wider rubber as well. More tire to handle the load and more mechanical grip to make use of the aero. Last piece back here is the diffuser, and it's grown significantly compared to the T50s. The fan is also supporting that diffuser. The T50 runs the fan in 6 different modes depending on what you're doing. The T50s simplifies that to 1. Flat out, all the time. So, splitter, dive planes, fin, wing, diffuser. Each one of those pieces adds load, and each one needs structure behind it to withstand it. When GMA first ran their CFD simulations, they were at one point hitting 1900 kilos of downforce. But they pulled it back to 1500 on purpose. Murray says it's about keeping the car manageable for its owners. I'd imagine there's an engineering side to that as well. Another 400 kilos of downforce means more load through the tires, suspension, and structure, and you're adding weight and complexity just to carry the extra load. Somewhere in there, manageable for the driver and manageable for the engineers building it probably overlap. Either way, even with all of this hardware, they held back. Which brings us back to the question we started with. With all of these aerodynamic elements, how does the car end up lighter? The T.50s V12 was already something special. Highest revving, most power-dense road-going V12 ever built, making 663 horsepower. The T50S pushes that to another level. Power climbs to 761 horsepower, helped in part by a newly designed roof-mounted ram air intake. That scoop is ramming extra air into the engine as speed builds, replacing the T50's induction setup with something purpose-built for this car. The exhaust changes too. It's straight through now. No catalytic converters, no mufflers. On the road, both are mandatory. On the T50S, there's no road to be legal on, so they are simply gone. It's lighter, louder, and one of the best sounding versions of this V12 yet. Add it all up, and the engine ends up 16 kilos lighter, roughly a 10% cut on something that was already the lightest production V12. For an engine, that's a serious number. And this is where it ties back to something we saw earlier. Remember the barge boards? The engine and transmission oil coolers have been moved off the back of the car and into the side ducts instead, positioned right behind the front wheels. GMA says it helps the car's center of gravity by seating those coolers lower into the chassis. Look at the rear of the T50 and you see how much open mesh dominates that area. On the T50S, that space shrinks a lot. My read is that the diffuser has grown so much that it eats into the available room. And GMA compensates with a handful of narrow slits cut into the bodywork instead. And the next place to look is everything the T50S doesn't need anymore. A road car has to comply with hundreds of pages of regulation before it's allowed anywhere near public roads. And those rules aren't even universal. The T50 is homologated for the UK and Europe, but not the US, where its central driving position and emissions don't meet federal standards. A track car never has to look at any of those pages, anywhere. Start with the front splitter. Pedestrian impact rules are strict about how low and how sharp the front of a road car can be. A splitter this aggressive would likely never pass a certification in most markets. Once the T50S doesn't need to be road legal, that limitation is gone. Look at how much tire is exposed at the back. The T50 covers most of it. Road cars have to, because bodywork must shroud a certain portion of the wheel. The T50S shows more than half the tire's height. Whether that fully clears what's allowed on public roads, I can't say without GMA's own homologation data, but it's far past what a road car gets away with. Move to the rear as a whole. No license plate, no plate lights, no reverse lights. None of that serves a purpose since the car will never be registered. Then there's the mirrors. And this one's a step backwards in technology. The T50 uses camera monitoring systems instead of physical mirrors. The T50S goes back to conventional wing mirrors. In theory, cameras should win, no drag-inducing housing sticking out into the airflow. But CMS comes with a trade-off. 2 screens, 2 cameras, wiring harness to connect them, and an additional ECU to run the system. All of that is expensive, and all of it adds weight. Physical mirrors are simpler, and once the car is not fighting for interior space to house screens and their wiring, ripping out the trim around them gets easier too. I can't say for certain which side of the trade won without GMA's own numbers. But if I had to bet, cost and simplicity mattered more here than the small aero penalty. The safety hardware goes the same direction. No airbags, no seatbelt retractors. In their place, a 6-point harness, which is lighter than either. None of that would pass any road-legal crash requirement. It doesn't need to. It's part of why the steering wheel could shrink down to a small yoke. Without an airbag to package inside it, there's less wheel that needs to exist. On their own, none of these changes look significant, but add them up and you start to understand how much of a modern car's shape, weight, and cost has less to do with performance. It's the compromise that comes with driving it on public roads. Stepping inside, the road car's 3-seat layout is already gone. The T50 fits a driver in the middle with a passenger either side. The T50s keeps that central driving position but drops down to 2 seats. And if an owner wants, they can delete the second seat and go single-seater. Where the passenger footwell would normally be, there's a vertical switchgear panel instead. Buttons and switches for functions like wiper control, suspension settings, and the ignition. On most cars, a lot of that switchgear and the electronics behind it are packaged underneath the dashboard, hidden behind the trim you never think about. Once that trim comes off the T50s and the dash gets stripped down, those systems still need to physically exist somewhere. They just don't have anywhere left to hide, so they've been relocated into this panel instead. Which brings us to the dash itself. On the T50, it's fully trimmed, multiple screens, a full array of switches. On the T50s, almost all of that is removed. What's left is mostly air vents and a single digital screen showing engine data, tire pressures, temperatures, lap times, G-forces, and whatever the driver needs mid-session. Look at the doors and up the roof and the logic is the same. No trim panels, just the raw carbon fiber structure left exposed. Another example is the steering wheel. Small, rectangular, almost yoke-shaped. We already covered why it could shrink once the airbag was gone. But Murray's mentioned a second reason. He used to make his drivers take their watches off before getting in a race car because of steering inertia. Anything heavy sitting out at the rim of the wheel makes it harder to turn quickly. A smaller, lighter wheel means less resistance working against the driver. The glass changes too. Most of it, aside from the windscreen, is polycarbonate, not glass. Lighter, and on the T50s, the side windows are fixed in place rather than able to roll down. No motor, no regulator mechanism, no window seals needed to make a moving pane work. One less system in the car. There's no infotainment system, no speakers. Nothing in here exists unless it's doing something for the driver in the moment on track. Before we wrap up, it's worth wondering why the T50 is so light in the first place. Because the answer isn't only the carbon fiber. Every hypercar at this price uses carbon fiber everywhere. That's not what sets the T50 apart. It comes down to size. Park it next to a Koenigsegg Jesko and the T50 is reduced in size across the board. 4.35 meters long versus 4.63. 1.85 meters wide versus 2.03. Even shorter in height at 1.16 meters versus 1.21. It's simply a smaller car and it still fits 3 seats. Smaller car means less material, less structure to hold together, less surface area of body panels. That's the foundation for everything. 957 kilos dry on the T50. Now watch what happens to get to the T50s. Some features get added: the wing, splitter, fin, diffuser, dive planes, barge boards. The structure needed to carry 1500 kilos of downforce. Wider tires, even the mirrors add weight back, going from cameras to physical glass and housings. But almost everything else comes out. No airbags, no seatbelt retractors, just the harness. No infotainment, no speakers, no CMS screens, cameras or wiring, fixed polycarbonate glazing, no motors or regulators behind it. Interior trim is practically gone, and raw carbon fiber is left exposed. The engine, 16 kilos lighter, the exhaust, no catalytic converters, no mufflers. No heater either. In fact, the car has no HVAC system at all. The vents you see feed ambient air. Nothing heated, nothing cooled. It's a system most people never think about, but it carries considerable weight. The T50s isn't painted either. The car is wrapped instead. Paint carries weight. Most cars have a kilo or 2 of it. And the multi-layer finishes you see on something like a Koenigsegg can reach 5 kilos. A wrap gives you the look without all that mass. And the body panels underneath are thinner than the T50s. That likely comes down to 2 things. Without road car crash standards to meet, GMA doesn't need the same level of panel stiffness. And there's no reason to chase that solid, no-flex feel manufacturers build in for perceived quality. Truck customers aren't touching these surfaces every day, so the car doesn't have to carry the weight. The wheels are made out of magnesium, under 6 kilos each. A small number on paper, but wheel weight matters more than most weight on a car, because it's unsprung mass. The suspension has to move that mass every time the car hits a bump or changes direction. By cutting weight here, the car not only gets lighter, but also reacts faster. Add it all up, and the T50s comes out 852 kilos dry, down from 957 on the T50. 105 kilos lighter, while generating almost 3 times the downforce. So weight and aerodynamics were never at odds, they were working side by side. One added the hardware needed to generate downforce, while the other stripped away everything the car no longer had to carry once it no longer needed to be a road car. The T50 and T50s make different compromises. Built by the same people, from the same philosophy, they pursue 2 different goals. One balances performance with the realities of the road. The other strips those realities away and focuses on nothing but the drive. If you had to choose just one, road car or track car, which one would it be? Thanks for watching, and I'll see you in the next one.